Hello everyone, this is the video lecture for Calculus 2, section 6.1, Area Between Curves. This is the first lecture in our Calculus 2 lecture series. I actually find this section pretty easy. We're going to start with a formula. We got area is equal to integral from a to b of top minus bottom dx. This is very unofficial. Top and bottom, they're just separate functions. It kind of just depends on the situation. For example, let's say I have two different curves here, and I'm going from A to B, and I want this area here. Well, obviously we have a top and a bottom, right? When we have two functions in terms of y, that is basically something kind of like sideways stuff, or who knows what's going on here. And we'll be seeing these. Top and bottom is relative to the axes of the independent variable. So it would be something kind of like this, and we have a top and a bottom that way. But we'll be seeing that later. Just focus on that one for right now. It's good enough. That's a B. Sorry, it's on an L. Sorry about my bad handwriting. Anyways, let's... I actually have an example here that's not on the homework, and I just want to kind of start with it. So I have f of x is equal to x, and I have g of x, which is equal to x squared. And so I've labeled this as top and bottom like this, and you might be wondering, well, hold on, isn't x squared like really big here? Well, I haven't told you the area that we're looking at. It's actually going to be 0 to 1. So we have a my x, and I got my x squared. See, x squared. But notice that from 0 to 1, x is actually on the top, and x squared is on the bottom. And so, although x squared looks like it's bigger, so it should be on the top, and generally, yeah, if it's past 1, we have to draw our graph and see what we're looking at in order to be able to get the right answer. So my area here is pretty easy, 0 to 1 of top minus bottom. I'm going to integrate x squared over 2 minus x cubed over 3 from 0 to 1. The 0 cancels everything. The 1 makes it really simple. When you do the math, you get 1/6. There you go. Let's keep going. 61003. So this is on your homework. If you're new to this style, I actually list out, it's not question number 3 on your homework. It's probably question number 1 on your homework or something like that. But the 003 is the identification, like ID number for this question. It references actually back to the book. So on the book, it's question 3 in that section. But I'm just doing it from WebAssign. WebAssign uses these IDs, and so I'm going to use them as well. Okay. And I'm not going to have the perfect graph here. I'm trying my best. I've got a super crazy problem for number 1, basically. X is equal to y squared minus 8. And then I have over here, x is equal to e to the y, and they're wanting to go from y equals 1 to y equals negative 1. Now, I said that backwards. We're actually going from negative 1 to 1. We want all that area here. And so, regardless, let's just pause for a second here. This is the first question on your homework. Basically, I can't really remember if it's literally number 1 or number 2 or something, but it's really up top on your homework. This is the first section in this class, and they're already giving you something really weird. This is going to happen sometimes. I highly recommend watching these videos first. And sometimes it's almost better to skip 1 or 2 problems and kind of go to something that's easier. A lot of times, the top problems on the homework were designed to be kind of like they're continuing from a different section, or they're trying to show an example of something you've seen in the past. I don't always agree with it myself, but we just do what we do. And I myself might skip around, but I would definitely warn you if I do that. Anyways, let's just find this area. So as far as top and bottom is concerned, I think that I'm going to call this one my top and this one my bottom, because this one here is more positive. like we're reading this way, okay? Independent variable here, x and y and all that kind of stuff. So from the axes, these are more positive, that's more negative. So this is on the top and this is on the bottom. Kind of like my example I was showing right here. But let's just do this thing. So I got my top, I got my bottom, and let's put it all together. Area is going to be equal to integral from -1 to 1 of my top, which is e to the y, that's my top, minus the bottom, which is y squared minus 8, that's my bottom, dy, not dx, it's dy, because we're using y's and stuff like that. Though, honestly, this is going to be a pretty simple integral. E to the y is going to go to e to the y. Cool. This minus sign, what I'm going to do is distribute it first, and so I actually get negative y squared. So I got negative y cubed over 3. 2 negatives here make a positive 8. 8 is going to go to 8x. Nope. 8y. Because again, we're using y's here again. We always have to remember that kind of stuff. From -1 to 1. What I had to do here is just plug it in straight in. It's a little silly, but it does work. And when I plug in the -1, I get something similar. There we go. Now, to simplify, I would distribute this to each term. Notice what I'm going to have is a negative here and a positive there, which actually coincides with them. They don't cancel, they combine like this. You can actually put these together as well. I think I used a calculator for that. What I got was e minus 1 over e, and then plus 46 over 3 as my constant. Well, I guess it's all constants, but whatever. Cool. There we go. So again, that -1 in the power makes it a fraction. All this combined to this thing. Let's just pause for a second here, guys. So I really don't like simplifying, and if you type this into WebAssign, it will work. It will work. I'm not saying it might work, it will work. And if it doesn't work, then you mistype something. I'm serious. You do not need to simplify. I'm going to simplify at times, of course. I'm the teacher, I got to do that. And that's cool, but you do not need to simplify on any of these problems. The only time you have to simplify is when they literally say to, and I don't know if you actually have to do that in Calculus 2. I can't remember. Mainly that's like a pre-calculus thing. And even then, it's very sparse, I would say. Next problem. So I got y equals e to the x. I got y is equal to x squared minus 1. I got x is equal to -1 and x equals +1. And they say find all of the area in between the bounds, bounded by these functions or something like that. So let's graph this thing. I got e to the x, so it's going to do something like that. Here's my e to the x. I got this x squared minus 1, so it's actually has a y-intercept at -1, and then it does this parabola thing. I don't know if it goes straight up past it or not. I'm just going to put something that looks like this. It's probably fine. And then I got my -1 to 1. And there's my area that I'm looking for. So again, you can see that this guy here is going to be on my top. This guy's going to be my bottom. And so here we go. Area is equal to integral of -1 to 1. Again, my top is the e to the x. My bottom is this x squared minus 1 and dx. Integrating is super easy. Remember to distribute. So x cubed over 3 plus 1x, I guess you could say, -1 to 1. You're going to plug it all in. Blah, blah, blah. I got e minus 1 over e plus 4/3. Very similar to the last problem. I'm not really caring too much about that. I just wanted to show there was a normal problem on your homework, and they're not always weird with the dy or whatever it is. Let's do another one. So I got y is equal to tangent of 3x, and then I have y is equal to 2 sine of 3x. That's sine. They give me the bounds of -pi/9 to pi/9. Let's draw this thing before we find the area, of course. Let's draw this thing to understand what's going on. Tangent basically looks like this. This is my tangent. So that's pretty easy. The sine basically starts at 0, so it's going to do this kind of number like that. And so it just so happens that negative pi over 9 and positive pi over 9 are at the intersection right here, at the first intersections. So they want that area there. It should be more symmetric, and that's actually a key to doing this problem quickly, is that you have two identical areas. So to find the total area, what I'm going to do is 2 times, and then my integral of one side. And so that's going to be only 0 to the pi over 9. And I'm hoping that 0 is going to simplify things, so I don't have to do all the math twice and all that kind of stuff. So then I got my top and bottom. Let's see here. I got my top as the sine. My bottom is going to be the tangent. So my 2 sine 3x, that's again my top. And then I got my tangent of 3x, which is going to be my bottom, dx. And now I just got to simplify. I have a little note here. Oh yeah, double because it's symmetric. Okay, cool. So I don't always remember every single one of these integrals. I would say for the homework, have like the integration tables and stuff kind of ready and available. I mean, sine is pretty easy, but tangent, what's the integral of tangent? Well, it's not secant squared. That's the derivative. So like trying to remember these things, it's always good to have some kind of note card or something like that available, like a sheet to kind of look at when you're doing the homework. And so let's do this. I'm going to leave the 2 in the front. My integral of the sine is going to be a negative cosine, but I'm going to have to divide by this 3. And so what I actually end up with is a negative 2/3 cosine of the 3x. Now, I did a lot of u substitution here and stuff, but I know that I can do that, and I want to do that with you if you absolutely need it. But this is a very simple integral, and I want you to think like that. I want you to see sine of ax and say, well, that's simple because it's not a big deal. You're just taking that number and dividing by that number. That's all. So don't overthink it, okay? And so then what's the integral of this guy? Go and look it up. It actually is ln of secant. And here's the thing, because of that u substitution stuff, you got u is equal to 3x, du is 3dx, da-da-da-da-da. Again, you're just dividing by the 3. Just like you had this 3 here divided by it, you're doing it here too. We could make it elaborate. We could make it more formal. I'm not a formal kind of guy. I just say, look, this is a simple one. We want to keep it simple. Don't overcomplicate it. Okay, I have to distribute this 2 still, of course. So let me just at least do that to make it look a little bit more pretty here. That's still a negative. Let's do a 1/3 in the front. I'm not really sure if the absolute value sign is required at this point or not. Probably not, but we'll see. So what I need to do is plug in my pi over 9. And I'm going to definitely get some values out of this. Now, notice that we got the 9 and the 3 are going to cancel to make a pi over 3, which is actually something we have on our unit circle. Do you have that memorized? Or at least do you have it on a piece of paper beside you? So it would definitely be helpful to have the unit circle stuff available at times. This is a perfect example. Hey, what's the cosine of pi over 3? What's the secant of pi over 3? Both of those are just unit circle values. I need to still plug in the 0, and sometimes it cancels. This time it doesn't. What happens is that when you plug a 0 into these guys, they don't make a 0. See, sine of 0 is 0, but cosine of 0 is a 1. And so what you're actually going to get is all this stuff here, minus, and then I'm going to plug in the 0. This whole thing goes to a 1, so negative 4/3. And then here, again, this whole thing here goes to a 1 on the inside. But it's kind of weird because what happens is you have ln of 1. Do you know what that ln of 1 is? It's 0. So you can just basically cancel that guy out. Simplifying a little bit more, again, we were talking about this. Unit circle, we got pi over 3 is basically 60 degrees. My cosine is a smaller one, and so it's going to be a positive half. And this guy right here is the inverse of that, so it's going to be a 2. So this is a half. This is a 2. You might have heard me, and I went very quickly through that. I said, hey, my cosine is the smaller one. See, we got 60 degrees. Cosine is my x value. It's this tiny little answer right here. Well, you only got 3 options, okay? Well, sorry. You only got 3 options. You got the square root 3 over 2, you got square root 2 over 2, and you got the half. If you wanted to see a pattern, it's technically square root 1 over 2. So which is the smallest one, right? We got 0.5. This guy here is a 0.7071, and this guy is a 0.866. So this is the smallest. He's going to be that small little x value right there, and that's how I just know immediately what that value is. I know that that's all pre-cal stuff. I'm just kind of reminding you because we will be using that same stuff as we keep going, and that's the kind of language that I'll be using as well. So let's keep going here. So simplifying this, we got negative 4/3 times the 1/2 minus 1/3 times ln of 2. No, it's not just 2, it's ln of 2. All that stuff. We've got minus and negative, so it's going to be a plus 4/3. I think that's it. So we're going to combine like terms and whatnot. These guys here make... the 2's actually cancel here, makes a 2/3. And with this 4/3, we'll make a positive 2/3. And then we just got this guy here. I feel like I'm missing something with this guy. Did I miss something? I have a 2 in the front of that ln. So where did that... Oh, right here. Right here. Look, guys. Look, look, look. I messed up on the very first video. I said, hey, distribute. Cool. And I did it. But then I forgot to do it here. Do you see that? That's a 2 there. So watch to the end. That's one thing. And just know that I have my notes here with me. I'm not just doing this all on the fly here. I actually have everything prepped. So I can go back and look at the answers that I have, which I got from WebAssign whenever I was doing the homework myself. So here's a good example. Very first video. I'm very glad we did this. I make mistakes. I make mistakes as we keep going. I'm leaving it in. I'm not editing this out because that happens. And you make mistakes. I make mistakes. Everybody makes mistakes. And that's okay. That's how we learn. So I needed to distribute that 2 over there. Now, technically, I shouldn't actually have 2 right there because it's right there. But that 2 should definitely be here. So that's a 2, 2, so on and so forth. I think there should be a 2 there, but it got canceled. Okay, so there. We all make mistakes. That's okay. It happens. There's your answer. Moving on. I'm not embarrassed by it. It happens in class too. If you're not making mistakes, well, I guess you'd be perfect. Nobody's perfect. This question is actually very simple, but I had to go and talk about it. It says use calculus to find the area of the triangle. Man, I'm so happy they talked about calculus. I mean, we're in a calculus class, right? So we got to do some calculus. And give me some points, and they say find that triangle out. Okay, so we got 0, 0. Cool. 1, 2, 3. 1, 2, 3, 4, 5. There's another point. Then we got 1, 6, 1, and that's a 6. Oops, right about there. There's my triangle. They want the area of that triangle. They say, hey, find the area of that triangle using calculus. No. No, I refuse. I'm not going to do calculus. Look at this. This is geometry. Or whatever it is. It's definitely not calculus. So what we actually have here are, I think, four triangles. 4 triangles, if you notice here. Let me use some coloring to kind of show you. We got one triangle right here. Okay, so we got that triangle right there. We got a triangle right here. And we got this bigger triangle right here. And of course the black one that we're looking for. What I'm going to do is I'm going to say, we got a rectangle, and I got 3 other little triangles, which I could definitely find, and then I'm going to subtract them and call it a day. So let's do this thing. My rectangle should be 3 times 6 makes 18. So the total rectangle is 18. Let me label these guys. So I'm going to say this right here is triangle 1, triangle 2, triangle 3. So let's do that. So triangle number 1, we have, if you notice here, it's 1, I don't know, what would you say that, height, width? I don't know. Because every triangle is 1/2 base times height. That's going to be my little area for each triangle. So I got a height of 1, and I got a base of 6. So let's do that. So I got 1/2 times 1 times the 6. And so I got a 3. Oh, I rearranged my... my notes are all kind of mixed up. That's okay. So triangle 2. I'll just put a T2, I guess. This guy up here, so the 1. Notice that we had right here, we got a base, I guess you could say, of 2. We got a height of 1, and so 1/2 times 2 times the 1. The 2's cancel, make a 1. And then T3, this guy right here, he's a bigger one. So we got a base of 3. We got a height of 5. So 1/2, 3 times 5. So I guess it's just 15 over 2. There's nothing to be done there. And so what I'm going to do is the rectangle, subtract all these guys, and that's my final answer. So 18 minus 3 minus 1 minus 15 over 2. And calculator action, I got 13 over 2. It was already on my notes. I was just pushing buttons to make it sound cool. This was an easy problem. You do not need to use calculus. Now, I don't know if they display how they get some of these answers on WebAssign. Sometimes they kind of show you the steps, or maybe you watch a video, whatever. They probably made like separate line equations for all these things and did top minus bottom. That is super awesome for them. And no. Just no. 61061. That's just a reminder. This is not number 61 on your homework. I mean, you don't have 61 problems on your homework ever. This is, I don't know what number this is. Maybe it's number 10 or something like that. But this is again, the identification number for this problem. I wanted to do this problem because it was confusing. And it actually is a lot of guesswork. I'm going to draw this as best I can, but it is not going to be perfect. And you're just going to have to forgive me. So it'll look something kind of like this. And they're colliding here at 2, and then somewhere over here they have a 4, because apparently that's important. I'm going to shade this little area in right here, tack this on, and I'm going to call this right here velocity. Okay. So the question is, there's a few questions. It says, which is ahead at 2 minutes? Which is ahead at 2 minutes? And honestly, the only options are A or B. So you got A or B, and you're going to pick which one, and that's the end of this. So obviously, with a multiple choice question like this, and you have, I think you either have 3 or 5 different attempts per question before that recycles and does a new randomization. Anyways, you can click A, and they'll say, no, you're wrong. And you click B, and it says, oh, you're right. And then all of a sudden, you got it right without doing any math. Congratulations, you made points on your homework. Yeah, I mean, everybody does it. I get it. That's not the point of the homework. The point of the homework is for you to learn, to train yourself, so that whenever you get to a quiz where you don't have the freedom to do that as much, and especially an exam, you're not just going to be clicking random things. You'll actually be, computing the answer. Okay, so that's one thing I want to say. A lot of times when I go through homework problems and it's a multiple choice, there's probably a concept that I want to talk about, or maybe there's something a little weird, but I would say most often, if it's just a straight up multiple choice or non-randomizing kind of problem, I tend to shy away from them, and I don't want to really talk about them much, because everyone's just going to toss the answer in and walk away, unless there's something really good there to talk about. I might just skip it on my lecture here. So which one is ahead after 2 minutes? Let's talk about what's going on. So we have velocity. This is not position. This is velocity. So we got 2 cars speeding up, and this guy's speeding up, and he's going really fast at first, but then he kind of slows down eventually, kind of just, he's not capping out, but he's not going as fast. So you're going from 0 to 50 like super quick, but then you go from 50 to 70 kind of slower, Well, this car, he's like, oh man, there's a green light now, so he starts off kind of slow. I'm going to get on it, but he's not really getting on it. He's kind of slow. And then he's all of a sudden getting a lot faster. He starts to get really fast. He has like top speed kind of stuff. And so then he starts to limit himself a little bit. So obviously A is going to be in front for quite a while. And A is your answer for this first question. Okay, so A, he speeds up super fast, so he's way ahead of the game, like a picture. Here, let me just do car A and car B, if that's okay. You like my cars? They're super awesome, aren't they? Car A goes boom, and car B's like, I'm gonna get there. Yeah, car A is definitely the winner after 2 minutes or whatever that is. Okay, awesome. So it now asks, what is the shaded region? What is the shaded region? Like, what does it represent and that kind of stuff here? It's the distance between A and B. So how does that work? So what we have here is velocity. And if you want to get the position, what you do is you integrate it and you find the position. Just like if you took the position and you took a derivative of it, you would equal, not just get, you would equal the velocity. So it's kind of like a back and forth. That's kind of what they're doing with this section. They're saying, oh, you're integrating tiny top minus bottom, and you would find the position. So that's your answer. You click that guy. It says now, which is ahead at 4 minutes. So the scenario's changed a little bit. Car A's cruising almost at a constant speed now, but B is like really getting faster. Who is actually going to win? This is actually guesswork. I mean, you would have to look at this. I don't think they gave you any kind of functions. You would have to say, like, well, what is this area here, and compute them both and compare them and see if you got a 0 or a negative or a positive, blah, blah, blah. The answer is just going to be an A. It's kind of a little weird, but what happens is that this negative area, I guess you can say, is still less than the area it has here, regardless of my drawing. Okay, so at 4 minutes, A is still ahead by a tiny bit. They're going to ask why, and you're going to say it's still positive. Again, like I said, you'd have that little negative area. This is a negative area right here, and you're adding it to your positive area. And whenever they flip, whenever your total answer is negative, then it means that B is past A. So still positive, blah, blah, blah. And it says, when will they be side by side? When side by side. Basically, when is the break-even point? And your answer here is 4.4 minutes, okay? Now, this is the one thing that you would have to type in that's not multiple choice. And let me just say, I have a little note here. It says this is an approximation. You need to use the grid on the problem. And so this thing is covered with lines, and you're going to just kind of add up rectangles and triangles as best you can. That's my word of advice. And I also have in my notes here saying, hopefully there is error tolerance, because I wouldn't want to have to do this problem 5 times just because I was off by 0.1 or something. So do the best you can. There you go. I know, I just kind of leave you at it. I don't create these problems. I just administer them as best I can. So there we go. Y is equal to 9x squared. I got y is equal to 9. And then it says find y equals b that evenly divides the area. Evenly divides the area. Okay. What is going on here? So we have this parabola, this 9x squared. Make that a little bit better. That's going to be good enough. And then we got y equals 9. It's going to be a flat line. That's better. So we got y equals 9. We got here 9x squared. And this is the area that they're looking for. They want to cut it in half. And you're like, oh, right there. Duh, 0. Yeah, no, hold on. It's y equals b. They're wanting a line this way that's going to cut that area in half. That is not as easy. And in fact, I would say that this is probably the hardest problem in this section. Okay, and that's why I wanted to do it. So now, how do we tackle this problem? What are we going to do? To find out, to evenly divide something, I'm going to find the total area first. So I'm going to call that the total area. And so I need to find this whole shaded region here. So in order to do this, make it a little bit easier, because it's symmetric, I'm only going to focus on this half over here and double it. And where they collide, actually it's at 1. It's kind of convenient that it's x equals 1 where they collide there, because you got the 9 and the 9. If, say, you have on your homework a 3 and a 3 or whatever, you would probably still get the 1. And so 2 times integral from 0 to 1 of top minus bottom. My top is actually just 9. That's my whole function, just 9. That's it. And then 9x squared is my bottom, like that. And we have to find our total area. This is not too bad, actually. It's a 2x. Here we got 9x cubed over 3, and some of that's going to cancel out. So we got 18x minus, actually, hold on. We got a 3 times the 2 would make a 6x cubed. The 0 will cancel everything. The 1 will retain the values, and we get a 12. So that's my total area. What then I want is half of my area, which is going to be a 6. Obviously, half of 12 is 6. And that should be the integral of something or other. Now, this is where it's going to be interesting. I want to now do the whole thing again. And I could do the 2 times business in the front still. But this horizontal line is what's dividing it. I could either do the top or the bottom, and I'm going to say the bottom is so much easier to do than the top. And let me show you why. If you have the top part here, like this section up here, you'd actually have to find a rectangle, and then you also have to find this little integral thing right there, and you add them up, and that should be finally equal to 6, or whatever it would be. Here I think it's 3 because it's going to be 2 and 2. Doing 2 separate ones is actually kind of difficult, and I don't recommend it at all. I'm going to do the bottom part, because again, these are half. It should be equal on both sides. So you're literally just going to have a top and a bottom, and you're going to find that area in between. Very simple. I mean, simple-ish. So I'm going to go again, 0 to what? It's not 1 anymore. Where are these colliding? You see what I'm saying? Where are they colliding? Where's this point right there? I don't know. But I do have a top and a bottom, so my top is actually going to be the b. And my bottom is going to be that 9x squared business. So this is the top, this is the bottom. And I'm going to just redraw this to remind you about what's going on. So I've got this right here going on. And I know there's another half of it over here and twice the amount and all that kind of stuff. So I'm looking at this guy. And I got my bottom, obviously got my top. My top is not 9 anymore. That's my y equals b. Just b, I don't know, it's just a number. And we're supposed to be going not to 1. Here's 1 out here. I don't know where we're supposed to be going to. How do I know when they collide? Exactly. So let's do a little bit of math to find out where that's colliding. I'm saying that b is equal to 9x squared, solve for x. I'm saying that this line is equal to that line, solve for x. So divide by 9, square root both sides, and we get plus or minus, which was expected because, again, this is symmetric. So square root of b over 3, you can put the 9 on the inside. It doesn't really matter. My notes, I have a 9 on the inside the whole way through. Here, I'm just going to put a 3 on the outside. It's both the same thing. So that's going to be my my end here. Now, I'm still saying this is 6 equal to all that. I know it's 6. My problem now is that I need to solve for b. And let me just real quick rewrite this thing so you understand the magnitude of why this is not an easy problem. Here, right here, this is all complete. Everything's good. There's nothing left to do mathy-wise. I just need to solve for b. And as soon as I solve for b, I'm done. So there you go. All right, so I set it up for you, right? Can I just move on now? Next problem, right? No, I don't do that. Very, very rarely would I do that, I would say. There's a lot of math going on, and this is not an easy problem. So let's talk about how to make this thing work. I guess what you could do to start with is divide by 2 on the other side. I did not do that on my notes, but, I mean, it looks logical, I guess. I want to integrate. I guess integrating is kind of easy. So b goes to bx, and then my 9x cubed over 3. And I'm going from 0 to the square root of b over 3. Okay, cool. Yeah, man. That's solving for b, sure. Whenever I plug it to 0, notice that they're both going to cancel, just like we did last time. So that's a good thing. So I don't have to worry about this one. I do need to still plug that in. And so I've got b times, and now this is going to be the square root of, you can see my b's look like 6s. I'm trying to write a 6. Here I got the square root of b over 3 and still cubed, and then all divided by 3. And again, 0 for the rest, so that doesn't really matter too much. This is where I'm getting a little confused because, I mean, I guess we can cancel, make a 3 right there, cool, but like, how do these guys combine, and what's this cube thing going on and all that stuff? Well, what's actually going on is that this is a 1 power and this is a half power. 1 times, well, it's not times. You're multiplying the bases, so you're adding the powers. So 1 plus a half is actually going to be a 3 halves. So we actually end up, we yield b to the 3 halves all over 3 there, okay? That's its most simplified form. On this side, again, I got a 3 in the front, and then we're going to talk over here. Well, this is going to be b to the 3 halves again. Notice that we got half, and we got a cube. That cube distributes, basically. So we have 1 half times 3 is 3 halves. Very thankfully, we have the same power here for both of my b's. Now, 3 right here is still going to be cubed, and 3 times 3 times 3 is 27, and so that's going to combine with this guy here in just a second anyways. We're almost there. I'm going to actually factor out a 3 halves b to the front here, since they both have it. Now I got a 1/3, and this guy should be a 1/9, and so what I end up with here is going to be, good question. I was thinking just 2/3, but I don't think that's right. So I got 1/3 minus 1/9, and my calculator says 2/9. Sounds good enough. Again, my notes, I did something totally different, and that's okay. I mean, we should end up with the same answer, I hope. So in order to solve for b, I'm going to multiply that to the other side. Basically, the 9's going to come up top and make a 27, and the 2's going to be in the bottom. And now we got this guy here, and yep, that's what I have on my notes. Finally got back to the same thing. In order to solve for b, I'm going to actually take on both sides, I'm going to use a different color here, the power of 2/3. 2/3 power should cancel with the 3 halves. And so I get my b is equal to, I guess your exact answer is this stuff to the 2/3. Nobody cares about that. So you go and put that in the calculator, get 5.6696447. I don't know how many decimal places they want, but I'm pretty sure they want decimals. And there you go. We got it. Phew. One last question, question here, problem that I have for you, 057. So this is an airplane wing, and I am not drawing it well. I get that. It's just a representation. This thing is 150 centimeters in width, I guess. It's like the teardrop shape, and I guess I could draw it a little bit better. Gosh, that is not good. I'm blaming the stylus and stuff that I'm using. There we go. And so the wind, the air kind of passes there, and it causes lift. Okay. So we have this 150 centimeters across, and they say at 15 centimeter intervals, we get heights of, and then they start listing all the heights. I will not list them all out, but I will give you a couple. 5.4, 20.3, 27.3, that's a 7. 29.0, okay, good enough. So there's 10 of them, obviously 150, we got 15, 10 of them, okay, cool. It says find the area with the midpoint rule n equals 5. Midpoint rule n equals 5. Did y'all do midpoint rule in Calculus 1? I mean, I'm pretty sure we're doing something like that here in Calculus 2. And I'll re-describe it when we get there. So just in case you don't remember, or maybe you didn't see it at all, what they're trying to say is we got these 10 sections here, and I mean, I'm not going to be able to make 10 perfectly here, will I? That's close enough. So what we're going to do is say, hey, for each one of these little sections, we want the midpoint for those. And maybe I didn't draw these well enough, or maybe I didn't explain it. I don't know. Regardless, you're going to use these numbers here. and the next one here, and then the next one there. And so you're going to be skipping some numbers and using the other guys. And I think there's 5 of them or something like that. I have a big number line on my, yeah, I explained it fine. I have a big number line of what's going on here. Oh, n equals 5. That's what's going on. So you only have 5 boxes, 5 different sections here. So 1, 2, 3, 4, 5. There you go. Okay, so we're not using the very first number. We're using the second number, not the third number, but the fourth number. And da 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 da. Okay. Anyways, to be able to find the total area, you're going to take the 150, divide it by 5, not 2, 5, and multiply that by those midpoint numbers, 20.3 plus the 29.0 plus da 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 da. You got your numbers, you put them in here, you get your answer. And I got 3144. You probably will get something different, but I just wanted to show you approximately it's like 3,000 something you'll get. That's all I got for this section. So, that's good. If you ever need help on anything, just let me know. There's the Ask My Teacher button there on every homework problem in WebAssign. It goes right to my email and all that kind of stuff. Of course, Blackboard messages and email and all that other stuff as well. So, well, there we go. Thank you very much. Have a great day.